Hey there, everyone, Alejandro. Welcome back for day 124 of me doing the NeetCode 150 challenge. So today we're doing another math and geometry LeetCode medium problem. Without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 73, set matrix zeros. Given an m by n integer matrix, if an element is 0, set its entire row and column to zeros. You must do it in place. Directly on the input data structure without requiring extra space proportional to the input size. I see. So okay, I can't retain. I mean, okay, I could just do two loops, right? Okay, straightforward solution using m. Yeah. Yeah. Yeah, you just do two parsings, right? Where it's like what's the values? What are the values? Oh, it's just oh no, they can be this, right? I can just mark it something, right? Something unique, right? Right here, what I'll say is m comma n is equal to length of matrix of 0. Idea: in order to use constant space, whenever a 0 is detected, set all of the values in that row and column to -1, to some impossible value such as none. This is because even something as simple as tracking the row and column indices that need to be set to zeros will require of m plus n space. Okay, I see. Makes sense, right? You can do it with like just makes sense. Yeah, in either case, the algorithm will still be of m times n time, right? So you might as well make it constant space. Okay, so yeah, here we'll set everything to an impossible value. So here we'll say for I in range m, for j in range n. Well, here if anything we can specify row index and column index, right? If matrix of row index, col index specifically equals 0, doesn't equal 0, then we'll just do continue, right? Otherwise, we'll say I in range m, matrix of and yeah, this is still m times n space, right? Because or time, sorry. If I set the whole row and column to zeros, right, I do that work in here, but that way when I loop through them in here, they won't be 0, right? So at worst case, the total amount, so even though it looks like, more for loop nestings, it's in total, it'll still be of m times n time, right? Because here I'm just doing two more parsings. Matrix of I, col index equals none. For j in range n, matrix of row index, comma j equals none. Then here we'll say in range m, so row index equals 0, then this guy is equal to 0 if it's equal to none. right? If it is none, right? And now return matrix, right? Something like this will work. No? Here I'm doing, yeah, we'll call this row index, call index, there you go. No, eh? Why is this? Okay, this is not as simple as I thought. I mean, it'll just require more time, right? I mean, yeah. Yeah. This makes run no longer of m times n though. Okay. And this will be, sorry, row index and j. Yeah, so that's accepted, but now this is quadratic. So 200 to the power 4. Yeah, okay, so we have a working solution. So, okay, we have a working solution that is technically constant space, right? It's just now that it's quadratic in terms of time, right? It would be much simpler to do, okay, def set zeros, constant space. Self, comma, we'll just grab all this, right? Self.set zeros returns self.set zeros constant space, right? Not because we actually care about returning the matrix value, right? We could essentially set this to no return and it would still work. The point is that essentially we pass in this matrix as a reference into this function that we will modify. That's good. So yeah, so this is of, I guess, yeah, this is mn squared time of one space. Return self.set zeros linear time matrix. So here we'll say O of mn time, probably O of m plus n space or something. And here we'll just do that. Def set zeros linear time matrix. Alright? And now here what we'll do is something like m comma n is equal to length of matrix of 0. And then here we'll say for I in range m, j in range n, row indices, sets, call indices equals sets. If matrix of ij equals 0, we will do row indices dot add I, call indices dot add j. Then here we'll say row index in row indices for j call index in range n, matrix of row index call index equal, yeah, so this is of mn of mn, and here we'll have one last O of mn, right, which is much better than O of mn squared. Is equal to of n plus n space. Is equal to 0. For call index and call indices, for row index in range M, matrix of row index, call index equals 0. Return matrix, right? So something like this should work as well. Yeah, this should take a self. Yeah, so that's going to be way faster. So now I expect this to be better than 7ms. And there we go, exactly. 0ms beats 100%. There you go. Bada bing, bada boom. Very nice. Okay, so as always in all my videos, I do a quick recap if I was able to solve the problem. So for this one, I essentially solved it in 2 ways. One of which was because they asked us if we could do it in constant space solution. I actually don't. Yeah, I don't even know how would they do it in O of M and N space? Like, basically, I was like, okay, the intuitive way that I would solve this problem legitimately was this way, where I use O of M times N time and O of M plus N space, and then I figured out a way to solve it in O of M N squared time, but only O of 1 space, right? Like they wanted here. Now, in terms of O of M and N space, what do they do? Like, track every single index? Oh, I guess, yeah. You just, like, keep track, so you loop through everything. Here we could probably do something like def set zeros quadratic time return self dot set zeros quadratic time matrix hashtag of mn squared time of m plus mn space, or actually of mn time of mn space, right? Here we could just say linear space and here we'll just do quadratic space. Quadratic space. Yeah. Matrix and self, right? And the idea is that for this one, essentially what we could do, something like m comma n is equal to length of matrix 0. And then here it's like of m plus n O of mn space 0 indices set okay, I'll refrain from doing this, but essentially you go through everything. It might even be mn squared time because then you have to fill up everything and so on. This is just a bad solution straight off the bat, right? So why even waste our time writing it? Okay, let's get into the actual solution explanation. So here I have 2 ways of doing things, right? The very first one, which is the most intuitive one, is essentially like go through the entire, loop through every single element in the matrix, right? Whenever you find a 0, you know that you want to set the full column and the full index to zeros, right? So remember the column index and the row index. For example, here you had column index 1 and row index 1. So here I have 2 sets, 1 row indices and column indices, and I'm going to loop through the entire matrix, and every time I see a 0, I'm like, okay, I'm going to remember that row's index, so row indices that I add I. I'm going to remember that column index, so column indices that I add j, right? And this is O of mn time because you loop through the entire matrix. Now what I'm going to do is that, okay, for every row index in my row indices, I know that I want to set the full row or column essentially to zeros, right? So so for every row in row indices, I know I want to set that row to 0, right? Because there was an element in that row that was a 0. So here we'll say, and then for every column index inside of that row, we'll say matrix at that row index, and obviously column index for every single possible column in that row, we'll set it to 0. So we'll set that full row to 0, right? Now think about it. This is you know, n, and then row indices can be at most m in length, right? Because this is a hashed, right? So this is at most m, this is at most n, so this is an m by n time double for loop here. And same thing here, right? For every column index and column indices, we'll loop through every single row index because we'll set all the elements in that row to a 0. which involves every row, and we'll just say matrix of row index and column index is equal to 0, right? So this is O of m n time, O of m n time, O of m n time, and then return the matrix, and here we required O of m plus n space, right? Here I'll just, make it a bit more clear. We'll do it like this, m times n, m times n, O of m times n, there we go, m times n, of m times n time, and of m plus n space. There we go. Now, for the constant space solution, this is the first one that I actually wrote because I thought that's what I had to do immediately. Yeah, you must do it in place. In place, yeah. So in place says, an in-place algorithm is an algorithm that operates directly on the input data structure without requiring extra space proportional to the input size. Okay, so here, technically, by having linear space, right, I have m plus n space, which is indeed proportional to the size of the input, even though it's m times n, and it's much smaller than the size of the input, but it's proportional to it. As the input size grows, the bigger these sets might be over here, right? So it's technically proportional. So technically, by you must do it in place by the definition listed in Wikipedia, this is an invalid solution. And so we must do it this way, right? So here I might as well put it second. There we go. And so here we'll say, okay, here's what we will do. Here we'll have mn length of matrix and length of matrix 0 as usual. So here I actually have it written down. In order to use constant space, whenever a 0 is detected, set all of that values in that row or column to some impossible value such as none. This is because even something requiring... Yeah, so, okay, the point is that we'll essentially mark everything in that row or column to none. Edit. Any found 0 should not be set to none so that it can be looped over in the future so that its column and row related values also become none/0 or 0 later on. There you go. And we'll capitalize edit. Or we'll just put nota buene. There we go. Okay. Yeah, sad face. So this makes like the solution very slow. But the point is that here we'll go through every row index and column index in range m and n. And here we'll say, okay, if it's not 0, no problem, right? There's nothing to do here, so return 0. So just continue. Otherwise, here's what we'll do. We need a way to, in place, be able to realize like, okay, everything inside of this column, this row index and column index need to be set to 0. Now, the only problem is that, like, let's say that here you have this 0 and this 0 over here. So one way that I could do it, and what I was doing at the beginning, is essentially I'll be like, okay, let's set everything in this column and everything in this row to 0 because we saw 0 here. Now, the only problem is that we'll override this 0 over here, and when we get to it, it won't be 0, so we won't override these columns values that should also be 0s. So what we're going to do is we're going to set everything in this column and everything in this row to none, because no number in here is none, right? All the values are between this range of integers, so having a none is definitely not a valid integer from the original input, so we can be chilling with that later on. Right, because we'll be able to turn them into zeros without getting into trouble later on. And essentially, that way, what we'll do is we'll set everything in the row or column where we find a 0 to none, except for other zeros. That way, when we get to those other zeros, we'll go through the entire row and column again, right? But even though that's extremely inefficient, right? For example, this 0, we'll set all of this row to nones except this 0. And for this 0, we'll reset everything into nones except the zeros, even though they're already none or 0 in the first place, right? Again, we can't keep track of rows or columns in which we've already done work for, because that would require linear space, right? So that's kind of the point. So here we're sacrificing time in order to save up on space, right? So the best solution is probably to just take linear time and linear space. But if you want to take constant space, then I found a quadratic time solution, right? So I just blow up the time. But hey, if for some reason space is really the issue and time isn't, then okay, great. Here's in-place algorithm that'll do it, but just much more slowly, right? But that's kind of the idea. So for every single element in a row or column wherever I find a zero, I'm going to set them all to none except the zeros, right? So that way it's like here I'll set these all to none and none except the zero. So that way when I get to the zero here, I'll replace everything in this row and column except zeros to none, so that I'll actually be able to grab this column, for example, right? This won't have become a none, and then I'll be like, oh, do nothing and so on, right? So that is kind of the point, right? And yeah, and then at the very end of the day, essentially every zero and everywhere there was a zero, its row and columns will all be none at the end of the day, right? So then I just re-loop through the entire matrix one last time and I say, okay, if anything is a none value, it was like, you know, something that was transformed from zero to none, or because it was in the same row or column as another zero, I'll just set all those none values back to zero, right? And then that way I'll have the matrix that I actually wanted. But again, this required O of m squared times n squared time and constant space, right? In my opinion, like, you know, this solution over here is a better solution. But again, if this is what they want, then this is what they get, right? That is kind of the point. And yeah, that's pretty much it in terms of how I was able to solve this problem. Like, just set everything to none except for zeros so that you can loop through them again. And so whenever you find a zero, right? So if something is not zero, I continue. Otherwise, I come in here and like, okay, for every single thing in this row, as long as it's not a zero, I'm going to set it to none. For everything in this column, as long as it's not zero, I'm going to set it to none, right? And that way it's like, you know, the things that are not zero, I didn't set them to none, but that's because when I go through this for loop, I'll reach those zeros eventually. And again, for everything in that row or column, I'll set them to zero again, blah, etc., 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 right? And if I submit this, we'll notice that I won't have a 0ms beats 100% solution. I'll have like, you know, 4ms here, because again, I made my solution, you know, quadratic in terms of the size of the matrix, right? But I do so at the benefit of only using constant space, making this algorithm in place as they tell us to, right? So now we follow that constraint. So there you go. We were able to actually legitimately solve the problem. So there you go. Bada bing, bada boom. Very nice. And yeah, so, you know, hopefully that solution makes sense. And as always, we can come over here and make sure that we check off the fact that we did this problem. So there we go. Hashtag very nice. Only 3 left for math and geometry. More importantly, 5 left in total for the NeetCode mediums. Feels very, very nice. Coming nice to an end. But okay, otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.